Right. So today we will discuss 2023, right? Within brackets 2022 quadratics question paper, right? Now I will summarize the problem, right? Now it is given that 0 greater modulus p lesser 1, right? And it is also given that p squared x squared minus 2x plus 1 equals 0 has real, different roots, right? And also in the question it says that let the roots be alpha and beta, where beta is greater than alpha. Beta is greater than alpha, and it asks us to prove that alpha and beta are positive. So we have to prove that alpha and beta are positive. That means we have to prove that the roots are positive, right? So now it says that this equation has real different roots. So if the roots are real and different, we know that the discriminant must be definitely greater than 0. If the roots are real and different, definitely the discriminant must be greater than 0. So what is the discriminant of this one? If this is the equation, discriminant will be b squared. Considering in the usual format, you know that ax squared plus bx plus c equals 0, right? B squared is 4, b squared, because b equals minus 2 when considering the given equation. B is minus 2, and what is a? A is p squared, c is 1, right? So b squared is 4 minus 4ac, 4 times what is a now? P squared, right? What is c? 1. That means 4 minus 4p squared greater than 0, right? 4 we can take as a factor, 1 minus p squared greater 0. Now 4 is a positive constant, right? Positive number, right? So that means 1 minus p squared must be greater than 0, right? That is one condition, right? 1 minus p squared greater than 0, that is one condition, right? Now the roots are alpha beta, right? Now if the roots are positive, there are certain conditions. Consider, now we know that if you are going to consider a quadratic equation, ax squared plus bx plus z equals 0, right? You know that. What is the multiple of the two roots? If it is a squared plus bx plus c equals 0, right? We can make the format like this. X squared, divide the entire equation by a, bx by a plus c by a equals 0, right? X squared minus x times minus b by a plus c by a, right? And also we can use this format. If the roots are alpha beta, according to the general format, consider this: if the roots are alpha beta, that means if x equals alpha or x equals beta, we can go in the reverse manner, right? X minus alpha times x minus beta equals 0, right? So then x squared, if you simplify this, it will be x squared, right? Minus x times alpha plus beta plus alpha beta. Look at here. The multiple of the roots are given at the last constant term. Minus the coefficient times minus x times, this will give the addition of the roots. So now if the roots are positive, what can you say about the last term, the constant term? That must be a positive number. But be very careful. Even if both the roots are negative. Now say both the roots are negative, so then also this final constant is positive. So that is a one condition. So just because like both the roots are positive, you cannot say the only condition. No, you cannot consider having a positive constant as the only condition, right? Anyhow, that is like half of the required conditions, right? Got the point? Because even if both the roots are negative, you can get the final constant positive, and even if both the roots are positive, so then also you can get the final constant positive. So luckily, now if you are going to consider the final constant, right? Now what is the given equation? P squared x squared minus 2x plus 1 equals 0. Now this is the given equation, right? So I will change the format like this: x squared minus 2x divided by p squared plus 1 divided by p squared. Okay, got the point, right? Equals 0, right? So now now here already we have one condition there. 1 minus p squared is greater than 0, right? So that means 1 is greater than p squared, right? And also it is given that, anyhow it is given, now this is one condition, right? Be very logical. 1 minus p squared is greater than 0, and that is one condition, right? And also it is given that if I go to consider the modulus of p, that is anyhow greater than 0, lesser than or, so anyhow this p is also a positive number, right? So definitely no doubt that p is also a positive value, right? So now consider the multiple 1 divided by p squared. So this is also a positive thing. What? This is also a positive thing, right? Because this 1 divided by p squared is the last term, that is the multiple of the roots. So this is also a positive term, no doubt, right? So one condition is satisfied. Now consider the sum of the roots. So now if you are going to consider this term, here we have minus 2x divided by p squared. So if you are going to consider it according to the format minus x times, so what will be that? So it will be minus x times 2 divided by p squared. right? So this 2 divided by p squared is the sum of the roots, right? P is greater than 0, lesser than 1. So definitely 2 divided by p squared is also a positive number. So that means the summation or sum of the roots is also positive. Multiple of the roots is also positive. That means definitely no doubt, right? Sum of the roots also positive. Product of the roots also positive. So then no doubt, then we can say alpha beta. We can say the roots alpha beta positive. That is how we are going to obtain the answer logically. Alpha minus 1 times beta minus 1 in terms of p, right? Hence, right, after using that result, we have to deduce that alpha is lesser than 1 and beta is higher than 1, right? So that is the problem, right? So now let's see. Okay, so we have to find alpha minus 1 times beta minus 1, right? And from the previous result, we know that alpha plus beta equals 2 divided by p squared. Check the working, right? And we know that alpha beta equals 1 divided by p squared. So let's multiply alpha beta minus alpha minus beta plus 1. Alpha beta minus alpha minus beta plus 1. So alpha beta minus times alpha plus beta plus 1. So what is alpha beta? 1 divided by p squared minus 2 divided by p squared plus 1. We can simplify, right? P squared, right? 1 minus 2 plus p squared. Then we are having p squared minus 1 divided by p squared. So this is the finalized answer for alpha minus 1 times beta minus 1, right? So what is alpha minus 1 times beta minus 1? P squared minus 1 divided by p squared, right? Now just look at this, right? What is now originally in the question it is given that the modulus of p. Now this is greater than 0, lesser than 1, right? Okay. So then what is p squared? So definitely no doubt p squared must be greater than 1, no doubt, huh? Okay. Now as this p is lesser than 1, right? This p is lesser than 1, definitely p squared also, no doubt, that is also lesser than 1, right? As p is lesser than 1, p squared also lesser than 1. So definitely no doubt this p squared minus 1, this term, right, must be a negative thing, right? This must be a negative thing, right? So no doubt about p squared, it is a positive thing. And if you are going to consider p squared minus 1, it is a negative thing. So then what can you say about the entire statement? So this must be a negative thing. This must be a negative version. I hope you got the point, right? So in order for a final statement to become negative, so definitely it must be some positive thing times negative one. So but now the problem is which one is positive and which one is negative. You got the point, right? We know that alpha minus 1 times beta minus 1 equals p squared minus 1 divided by p squared. Now this term is entirely a negative thing. So definitely the format must be positive times negative thing. And now listen, that means definitely one part of this must be what? A positive thing. Now if this is positive, this must be negative. Or if this is negative, this must be positive. Now in the question it is given that beta is greater than 1. Not greater than 1. In the question it is given initially beta is greater than alpha. Okay. In the question it is given that beta is something that is greater than alpha. So then we can logically say, if beta is greater than alpha, then we can logically say then this must be the positive term. That means beta minus 1 is the positive part, right? Beta minus 1 is the positive part and alpha minus 1 is the negative part. So that means beta minus 1 is greater than 0, alpha minus 1 is lesser than 0, right? Beta minus 1 is greater than 0, alpha minus 1 is lesser than 0, right? So then we can easily say if beta minus 1 greater than 0, this means what? Beta is greater than 1. If alpha minus 1 is lesser than 0, that means alpha is lesser than 1, right? Yeah. So that's it. They ask us to prove root beta minus root alpha equals 1 over modulus of p times square root 2 times 1 minus modulus of p, right? Okay. So now we know that, right? Now we know if the roots are alpha and beta, we know that alpha plus beta. What is alpha plus beta? That is 2 divided by p squared. What is alpha beta? 1 divided by p squared. We know that. So now there is a technique, right? So this is the method, right? Okay. So we have to find what is root beta minus root alpha. Okay. So the technique is this. Let's consider root beta minus root alpha whole thing squared. So what is the answer? Beta squared is beta, root beta squared is beta, minus 2 into root beta root alpha plus root alpha squared is alpha, right? What is the answer? It is alpha plus beta minus 2 times root alpha beta. Now alpha plus beta we know. What is alpha plus beta? 2 divided by p squared minus 2 is root of what is alpha beta? 1 over p squared, right? 1 over p squared, right? So square root of it, 2 divided by p squared minus 2 divided by p, that is the answer. Square root of 1 over p squared is 1 over p, right? But be very careful. What is the final answer? P squared, if you take p squared as the common denominator, 2 minus 2p. So 2 minus 2p divided by p squared. This is the answer for root beta minus root alpha whole thing squared. But we don't want whole thing squared. What we want is root beta minus root alpha. So we'll take the square root of it. So then square root of this will be root beta minus root alpha. Got the point? Right? So now you can further simplify this, right? It's like, now you can say root beta minus root alpha equals root of twice 1 minus p divided by p squared, right? So square root of 1 over p squared is what? It is 1 over p, right? Times you can keep the rest part as now always focus what is the given thing, right? Always focus the question and do, because in combined mathematics everything is given, right? You have to just you have to prove that. So see, if you take the square root of 1 over p, so it will be 1 over p square root of twice 1 minus p, right? Now here p, now here when considering p, what we refer is the positive format. So that is why here we have the modulus of p. So it is done 1 over p times square root of 2 times 1 minus p. So that part is also taken. So now previously that we have obtained this part, right? There is something that I need to tell, right? Focus, root beta minus root alpha equals 1 over p times square root 2 times 1 minus p. Now we have obtained that part, right? So, but in the question paper they have asked us to prove something like this, right? 1 over modulus of p square root 2 times 1 minus p modulus, right? The modulus p. Now this modulus p has a different meaning, right? Actually, what is the meaning of modulus? Now if you are going to consider modulus, means you are only going to consider the positive thing, right? Modulus means you are only going to consider the positive version, right? But this single guy has two lives. One is, what is one? The same thing with the positive coefficient and the same thing with the negative coefficient, right? Okay. So in case if there is this modulus p, that means it actually contains two lives, right? You got the point, right? So now previously we have proved that root beta minus root alpha equals something, right? As you can remember, how did we prove that? We have proved that in this way. Root beta minus root alpha, we have considered the whole thing squared, because if we consider the whole thing squared, then we will be getting something like beta plus alpha minus twice root beta root alpha, and this we can write as alpha plus beta minus twice root alpha beta, because the reason, now be logical, right? Don't memorize combined mathematics, right? Because alpha plus beta is the addition of roots, we know that. Alpha beta is the product of the roots, we know that. So that is why we proceeded like that. Okay. Now we know that root beta minus root alpha whole thing squared is alpha plus beta minus twice root alpha beta, right? Okay. But what we actually need is to find what is root beta minus root alpha. That is our target. Okay. So, but be very careful. There will be no problem for alpha plus beta, because we know that is 2 divided by p squared. Okay, fine. What is minus twice? What is root alpha beta? That is root 1 over p squared. But here now, as you can see in the final answer, it is given that root beta minus root alpha must be 1 over modulus of p times square root of twice 1 minus modulus p. Why is that? Now see, now we know that both the roots alpha and beta are positive numbers, right? Because you know the roots are positive. So now we know that both the roots alpha beta are positive numbers, right? Because both the roots alpha and beta are positive roots, right? So then no doubt the product of alpha and beta definitely must be a positive thing. But just because alpha and beta are positive, it results, ultimately it results a positive number alpha beta, right? But if you are going to take the square root of it, you cannot say that it only must be a positive number, because here you have to consider, for example, just consider alpha is 1, beta is 4, right? So then what is alpha beta? Then alpha beta is 4. Then what is square root of 4? Square root of 4 is, it can be either positive 2 or it can be either negative 2, right? So be very careful, right? So that is the scenario that I want to tell you, right? Right. Now in this problem it is very clearly mentioned that both the roots are alpha and beta, but beta is greater than alpha. And one point, we know that both the roots alpha and beta are positive, that is one thing, right? Okay, then no doubt. Okay, but it is mentioned that beta is greater than alpha. So then definitely if you are going to consider the difference, because now our target is to find what is root beta minus root alpha, right? So then root beta minus root alpha must be square root of 2 over p squared minus twice 1 over p squared. Okay, right. So here this ultimate answer definitely must be a positive thing. Square root, right, 2 divided by p squared minus 2 divided by square root of 1 over p squared. I will take it as modulus p, right? Okay, because even p into p also p squared, and even minus p multiplied by minus p is also p squared, right? But I am going to consider only the positive version, that means modulus, right? P squared 2 minus twice, no, modulus p, it is something like a positive thing, right? So if I am going to consider the LCM, twice p, right? And now if I am going to take the square root of it, okay, I will again go to the top, right? Because now I am going to consider the square root of it, root beta minus root alpha equals, right, square root of 2 minus 2p divided by p squared. 2 I can take it as a factor, twice 1 minus p, right, over p squared, right, square root of p squared. Because this root beta minus root alpha definitely must be a positive thing, so that is why I am going to consider only the positive version. So square root of 1 over p squared, I am only going to consider the positive version. So here also square root twice square root twice 1 minus, I am going to consider only the positive version, modulus p, right? They have provided us that root alpha plus root beta equals 1 over modulus p times square root 2 times 1 plus modulus p, right? So now they have given us that, right? And now they want us to prove that the equation with the roots, right, where modulus root alpha minus 1 and modulus root beta minus 1 is this one, right? Modulus root alpha minus 1 and modulus root beta minus 1 is this one, right? So what is this? Modulus p times x squared minus square root twice 1 minus modulus p times x plus square root twice 1 plus modulus p minus modulus p minus 1. So now, okay, so let's start. So now we have to evaluate the equation with the following roots, right? So then what will be that particular equation, right? Because we know that if the roots are alpha and beta, we can write that equation as x minus alpha times x minus beta equals 0, right? So that same procedure we can use here, right? So the equation with the roots, be very careful, you have to consider the modulus component, right? So x minus modulus root alpha minus 1 times x minus modulus root beta minus 1 equals 0, right? That is the equation with these roots, right? Okay. So now be very careful, right? So here now we know two relationships, right? One relationship is root beta minus root alpha equals this, right? Then the other relationship is that root alpha plus root beta equals this, right? But be very careful, right? So if you carefully look at the equation that we have to prove, right, 1 plus modulus p, such type of a part is not everywhere, right? So one particular part is there, 1 plus modulus p, one particular part is there, but not at everywhere, right? Carefully see. Now here we have 1 minus modulus p, right? Here we have minus modulus p minus 1, right? But so that is the case, you have to be very careful, right? So then that is the point, right? So in this equation, if you are directly using this relationship, right, to this equation, anyhow, after making certain arrangements, right, to this equation, if you are directly taking this root alpha plus root beta relationship there, you will not be able to reach up to this answer, right? So you have to be very, very careful, right? And the next part is that you know that how to expand a statement like this. If it is modulus p, it has two lives. One is positive p, other one is negative p, right? That is also one thing, right? Okay, right. So then let's start. Now here, if you are going to consider modulus of root alpha minus 1, there are two sides. Modulus of root alpha minus 1, there are two sides. One is positive root alpha minus 1. What is the other one? Negative root alpha minus 1. Right. For modulus root beta minus 1 also the same scenario, right? It has two lives where one is modulus root beta minus 1. So one is root beta minus 1 as it is, other one minus times root beta minus 1, right? So here I am going to do some change like this, right? Now here it is true that we have this modulus component, right? So now I will use that particular features of the modulus component, right? So x minus, okay, we know that this modulus root alpha minus 1 has two lives, so I will use one of it, right, which is minus times root alpha minus 1. I will use that relationship, so then I will be getting 1 minus root alpha. Got the point, right? Because minus times root alpha minus 1 is 1 minus root alpha, right? So I will use that relationship, 1 minus root alpha times, to here I will use just the positive version, which is root beta minus 1. Got the point? Right. Now let's carefully do the simplification, right? X squared minus x times root beta minus 1 and minus x times 1 minus root alpha. Positive root beta minus 1 times 1 minus root alpha, right, equals 0. Right? So now our ultimate target is to obtain this answer. What is that? Modulus p times x squared minus square root twice 1 minus modulus p. Be very careful. See, 1 minus modulus p, right, times x plus square root twice 1 plus modulus p. Okay, be very careful. 1 plus modulus p, right, minus modulus p minus 1, right? So now, and the other fact that we already know two relationships, right? So one is this root beta minus root alpha and the other one is root alpha plus root beta, right? So now, before making any sort of a step, right, carefully we have to observe, right, what sort of a relationship that we have to use, or what sort of a relationship that we have to introduce into the next step. You cannot find this component, right, in this equation at everywhere. You can see that you cannot find this statement entirely in this equation, right? So there is no point of directly introducing this root alpha plus root beta relationship into the next thing, minus root alpha beta 1 over p squared, right, minus 1 over p squared minus 1, right? Okay. So now again focus the given answer, right? Okay? the given answer we have this modulus component, right? So if I am going to take the square root of 1 over b square, right? You know that square root of 1 over b square has two different answers, right? Positive 1 over b and negative 1 over. Okay. But here we will consider the positive version of it. So we will write like square minus x times plus 1 minus modulus b plus 1 plus modulus b divided by modulus b minus 1 over modulus b, right? Because if I am going to consider the square root of it, we will consider only the positive version, right? Minus 1. Okay, so now I will finish the top part. So now we can simplify this one, right? How? Because here we can consider the least common multiple, right? So again I will write square minus x times, right? Square root twice 1 minus modulus b divided by modulus b, right? Plus now what is the least common multiple? That is modulus b, okay? Twice root twice 1 plus modulus b, right? Minus 1 minus modulus b, right? Equals 0, right? Square root twice 1 plus modulus b minus 1 minus modulus b, right? So now let's multiply the entire equation by modulus b, right? Let's multiply the equation by modulus b, right? Why? Because modulus b is already greater than 0, right? And also it is a non-zero value, right? So we can, without any doubt, we can multiply. So what is the answer? Modulus b times x squared minus x times square root by 1 minus modulus b, and this part taken, fine. Then plus square root twice 1 plus modulus b. Yeah, this part also taken, right? Minus 1. Yeah, okay. Minus modulus b. Equals to, right? From here. Right? Minus x times. Beta minus alpha. This minus 1 to plus 1 will cancel, right? Plus minus 1 plus 2 beta minus 2 alpha beta plus 2 alpha, right? And x squared minus x times, right? So we will arrange in a format by showing the known terms, right? So that we can easily substitute. Beta minus 2 alpha plus 2 alpha plus beta, right? Minus 2 alpha beta minus 1, right? Okay. So then x squared minus 6 times. So now this we can substitute, right? You know what is root beta by root alpha, right? Now we just put x downstairs, right? Twice 1 minus modulus 2, right? Then plus root alpha plus root beta, you know that, right? It is here modulus p square root twice 1 plus modulus p, right?